Welcome to the final module of the CCNA lesson number 5. Lesson number 5 is mainly based on the IP services. So I'm going to take you through the concepts and then through all the labs of the IP services, starting with NTP and Syslog, followed by DHCP, and then we have got a lab on SSH, CDP and LLDP. And then we are also going to take a look into IPv6, the foundational part and a lab on that, and having a little bit of basics on the automation with the next steps which you are going to take after completing the CCNA course. So all the best. IP services. So we have got a couple of them, and a few of them I have showed in the lab with the commands and how they work. And let's take you through the all of the IP services here, starting with NTP, which is Network Time Protocol. So network time protocol means that if your networking devices are connected, okay, they all should work in a synchronized time. The time should be in sync with all the devices. Why? Because if the time is not in sync, then your devices will not talk with each other. Let's say OSPF, right? Your hello packets, your neighboring table, your database formation, nothing will be working because everything is based on your timers, correct? So that's why NTP is a must, and I have shown you in a lab how NTP works and how to configure it. SNMP, one of the popular ones, which is called Simple Network Management Protocol, and that's mainly used for monitoring the network devices and the bandwidth along with the CPU utilization. Okay, now both the NTP and the SNMP, they work on the layer 7. Okay, and the port numbers for NTP is 123 UTP, and the port number for SNMP is 161 or 162 UTP. Syslog is a mechanism to connect your or to capture your system logs, any kind of logs. Let's say that one of your link is down, right? Or any update is going on, any notification is happening. All those logs can be captured and stored. And in fact, even if your router is reloaded or rebooted, then also the logs will be there permanently stored. And looking at the logs, the network admin can find out a lot of stuff. Again, syslog works in the layer 7 protocol, and the port number is 514 UTP. Now, when it comes to syslog, which I'm going to show you in the lab, that there are particular severity levels, which starts from 0 and ends in 7. Now, the levels which are having the lower number, they are called the critical ones. So 0 will be the most critical one, and followed by 1, 2, 3, and the least one will be the 7th one. So emergencies, alerts, and critical, they are the critical ones which needs to be acted immediately, ASAP, right? Followed by errors, warnings, notifications, informational stuff, and debugging. So these are all the stuff which can be taken a little bit later, but the first few ones like 0, 1, 2, 3, 4, these are the ones which has to be actioned immediately. Other options in the IP services will be CDP. Now, CDP is called the Cisco Discovery Protocol that works in layer 2. And by default, this protocol is enabled on all the Cisco devices. And the way it helps is that by just typing in the command of the CDP, like show CDP neighbor and details, you can actually find out what are the devices connected to that particular interface of the device. But only the catch point is that this will be able to find out the Cisco devices. Okay. Here the hello timer is 60 seconds and the hold timer is 180 seconds. Okay, so 60 means that within 60 seconds the devices will be connecting, and hold means within 180 seconds. I mean, till that point of time, if the connection is not happening, then the devices will think that the other device is dead, okay, or not working. Now let's say if it's a non-Cisco device, like a Juniper device, okay, then how do you know that? Then you have to use the open standard protocol, that is LLDP, which stands for Link Layer Discovery Protocol. and that will help you to discover directly connected non-Cisco devices as well. I'm saying as well because it will help you to discover both Cisco and non-Cisco, but since the CDP will help you for the Cisco only, the LLDP is mainly used for the non-Cisco devices. And I'm going to show you both the commands in the lab. Okay, here the hello and the hold timer will be 30 or 120 second. It's like 4 times, right? The first one, the CDP, is 60 to 180, which is 3 times, and in the LLDP it is 30 to 120, which is 4 times. TFTP is again one of the IP services that stands for Trivial File Transfer Protocol, and that actually works something like this. Let's say you have got a computer with the operating system loaded on the drive C, and by any which case your OS gets corrupt, right? Then you will be having a backup there in the drive D, and with the help of the drive D actually you can backup and restore your laptop immediately, right? So similarly, for routers also, the iOS configuration, the backup and the restore can be done with the help of the TFTP protocol. Not only that, uh, the upgrade can also be done from one version to another. Let's say 12.2 to 15.x I want to go. I can use the TFTP as a TFTP server, and with the help of the TFTP server, I can actually use or upgrade the systems from 12 to 15. But the catch is that if you upgrade a router with from 12 to 15 with the help of TFTP server, the moment you reboot the router, it will come back to 12 again. So you have to use actually two commands there to ensure it is not going to come back to 12, it will stay on the 15. Okay, now there are a few of them like I have not shown in the labs, which you can just have a quick check from the books, and in the CCNA actually we are not going to cover too much of the TFTP which is covered in the CCNP level. QoS, quality of service. Now that's a huge topic, and most of the topic is covered in the CCNP level. Just to tell you in brief that QoS is something where it's a method of giving priority to some kind of traffic. And what is that? Let's say you have got traffic like browser or your web or mail and file, and you also have got a traffic like VoIP, right? Now, if I go in the method of FIFO, like first in first out, as we use in the hardware queuing, then that will not be helpful to us. Why? Because then VoIP will be coming in the last and going out in the last, which we don't want because VoIP is a real-time traffic. If you're on a VoIP call, let's say in a WebEx or in a Skype, you will like that audio to be transferred and received immediately, right? You just cannot say hello on the call and stay like muted for 2 seconds and then the person responds to you saying hello. You want that to be immediately heard and to be listened to. So we have to find a mechanism where we can do a software level of queuing. Okay, and that is called the QoS. Let's say the VoIP traffic has to be actioned immediately over your normal file traffic or mail traffic. Let's say you're uploading a file or downloading a file, okay, or you're checking a mail and the mail takes maybe 30 seconds more to arrive at your inbox, or you're downloading or uploading a file takes a minute more. It will not do any harm. But your VoIP, if it is not actioned immediately, definitely it will lead to a bad customer experience. So all this can be tackled with the help of QoS, where you can prioritize the traffic and say this has to be actioned in the beginning and this is a top queue, and that will be actioned in the beginning itself. So methods are there like WFQ, CBWFQ, LLQ, and so on, which again we are going to look into the CCNP level and check out the entire QoS. So followed by this, we have got labs where I've shown you the specific labs with the commands and with the services, which are kind of in scope of the CCNA syllabus. And few of the topics like TFTP and QoS have been left out because they will be covered in detail in the CCNP syllabus. All right, so welcome to NTP and Syslog lab. So let's first start off with the NTP lab and let's find out how the NTP works. So let me go ahead and pull up a router and let me pull up a server. So I will connect them and we have connected the router to this server, right? Now, NTP means that your device clock should match with the NTP server clock throughout the network. Okay, and if the clocks they do not match or there is a mismatch, then your protocols will not work fine. Like your hello packets in the OSPF or the neighboring or the database tables will not form at the proper timings because your clocks are not matching. So you have to make sure that your clocks in the NTP server and the other end of the devices, they are a perfect match. So this particular router, I'm going to name it as R1. And this server will be a NTP server. Now let me go ahead and give some IP address here. So this router R1 will be having, let's say 1.1.1.1, and the server can have 1.1.1.2, right? Now let's see how it works out. First thing first, I will go to the router and go to the interface gig0/0 and enable this particular IP address. So let's go to the router. Let me give the host name first. Okay. And then interface gig0/0 IP address 1.1.1.1, and I will keep it default. Subnet mask 255.0.0.0. Okay. And no shutdown, right? Press enter. And we are done with the configuration of the router. Come to the server and we are going to give it the IP address and the subnet mask 1.1.1.2. Subnet mask is coming up default, which is fine. Default gateway will be 1.1.1.1, which is the router. Now in the NTP server, I will go to the services on the top. In the services, you will see that we have got the services on the left hand side, and I will choose the NTP here. In the NTP, by default, it will be turned on, but still in the simulator, sometimes it will not work out. So you have to just ensure you turn it off once and then turn it on again. Okay, just to ensure it works out fine. Now here we are seeing a particular day and time, okay, 2021 Jan 10th with some time there, right? So similarly in the router also, we have to ensure that this is a synchronization with the timing in the router as well. So how do I check the time in the router? I will come to the router R1 and the command is do show clock. Okay. If you type in that, you will see the date and time is pretty far. 1st of March 1993. That means the synchronization is not there. So we have to make sure that the clock of the router is synchronized with the NTP server clock. And how do we do that? The command is simple. We have to type in NTP, okay, and then followed by server, because the server command is showing configure the NTP server. So go for NTP and then server, and it will ask you for the IP address, which is 1.1.1.2, the IP address of the server, right? Press enter. Now let's check how the clock looks like. Do show clock is still showing the same. So this command alone will not synchronize the clock. There are two commands which you have to give in the NTP in the router to make it work. The second command which you have to give is service question mark timestamps question mark log question mark date time followed by msec. Okay, press enter. Now these two commands, okay, the first one is this guy NTP server 1.1.1.2, and the second one is service timestamps log date time msec. These two will make sure that your NTP clock in the router is synchronized with the NTP server clock. However, the key point is that it will not happen immediately. It will take at least 1 minute to get it done. So in the exam, if you find a question like this where you have to synchronize the device to the NTP server, once you type in the commands, don't panic if it's not coming up within 10-20 seconds. You have to wait at least till 60 seconds to make it work. Okay. While it's coming up, in the meanwhile, I'll be showing you the verification commands for the NTP. Okay. So let's come out of this. And verification command, the first one will be show NTP association. Okay. And you will see the association here, of course, is 111.1.2. However, the peering has not happened yet. The peering means a star sign. Once the star sign comes up, that means at that point of time, your router is being peered with the NTP server. So that has not happened yet. And the second command is show NTP status. Okay. And here it tells you very clearly clock is unsynchronized. So you have to wait for some time till the clock comes up, and then only you will see that the NTP in the router will be matching with the NTP in the server. Okay. So now let's check. I think it's slowly coming up. Status, it is still unsynchronized. Nope, it's not there. Let's hold on. Okay. Let's go to associations. Still not there. Yeah, I think now it has came up. See, because this particular star is going to come. It is going to come up in some time. No, not there yet. Just hold on. So that's all about the NTP. I will just show it to you once it comes up. But just know that all the devices in the network, they have to be synchronized by one single clock so that all the updates, all the neighbors, all the hello packets and everything, they are traversing in the time that are by default enabled in the iOS. Okay. Now let's check associations. Yes, now do you see the difference? The star has come up in the front, which means the peering has been done and the NTP is enabled. So let's just check out the status now, and you will see the clock is synchronized, very clearly showing up. Right now, if I say to the router R1 that show clock, you will see the time has changed, right? Jan 10th, 2021. Very simple, but you have to have the patience in the exam also. Wait for at least 60 seconds for this to come up nicely. All right, so that's all about the NTP. Now let me show you the commands for the syslog. So system logs or the syslog, let me just pull up one more device here. Let me pull up a switch somewhere here. And let me connect it between this router and the switch. Pretty simple. And let's get a IP address here. Probably I will give it 2.1.1.1. Okay. Right. Just bring it here. Okay. Now let me go to the router R1 and configure gig 0/1. So let's do it. Interface gig 0/1. IP address. This is 2.1.1.1 and subnet mask is default 255.0.0.0, right? And I will say no shut. Okay. Now, the moment I say no shut, you will be seeing that this particular lines are coming up, right? Changed interface, changed state to up and all that stuff, right? Now, these all are called the system logs. Now, system logs, if you remember the slide I showed you, the different statuses there, right? From 1, 2, 3, 4, 5, and the least the number is, the critical it is, right? So here you will see the number is like 5. 5, if you check, the 5 is standing for the notifications. Now, these kind of alerts, if I want to store in a server, or if I want to store in the syslog server, I can store them, because these are right now stored in the flash, right, of the router. And the moment I reboot the router, these logs will be gone. but I would like to store them in a server so that even if I reboot the router, the logs will still be there. How do I do it? So to do that, I have to go for the server there, and under the services, I will check for the syslog. Here is the syslog. In the syslog again, by default, it will be on, but your job is to ensure that turn it off once and turn it on again. This is only for the simulator to ensure things work fine. Sometimes it will not work if you don't turn it off and on. Now currently it is blank, right? So I have to ensure that I have configured my router to the syslog server so that if any notifications are coming up in the router, any system logs are coming up, critical or notifications or anything, that will be logged or saved in the syslog server. How do I do it? So I will go to my router R1 and I will type in the command. The command for the syslog is very simple. Now before I type in the command, just have a look into this. The syslog page is blank, right? There is nothing in the page, right? Let me close this. Now the command is, I will come out of this and I will say logging question mark, and it will say host. Host command is set the syslog server IP address and the parameters. So I will say login host question mark IP address. IP address of the syslog server is 1.1.1.2, right? Press enter and it's done. Single command. Now how do I check it? Let's say I go to the interface gig 0/1, okay? 0/1, right? I will say shut down, enter. Some commands are coming up, some logs are coming up, and I will again say, let's say no shutdown, okay? And then I'm going to check in the syslog if something has came up or not. Let's see. And you see all the logs are showing up here. Now this is the message field. If you click on this, you will see the message gig ethernet 0/1 change status to this. Again, you will see this change status to down, change to up, and change to up and all that. So all your logs will be saved in the syslog server. Very simple, but pretty critical actually, because if any point in the network, some kind of errors are happening or some kind of link is up or down or anything is there, you get to know as a network admin looking at the syslog server that, okay, what are the logs there? And looking at the logs, you can actually find out what exactly went wrong at that point of time because your timestamps are here. Now note one thing. If I remove the NTP from the router, then also you will see the syslog logs there, but your timings will not match. Your timings will be kind of very incorrect and wrong kind of timings will be showing up here. So it's always it's a must to ensure that your NTP is synchronized and then you turn on the syslog server commands. All right, with that we came to the end of the NTP and the syslog lab. Hope you liked it. Thanks for watching. Cheers. Welcome to DHCP lab. So DHCP, the process itself is called DORA process. Okay, so there is a sequence of steps and we call it DORA, and the D stands for discover, O for offer, R for the request, and A for the acknowledgement. So let me pull up some devices and then we will go through the DORA process, how it works on a basic DHCP from client to server. And then we are going to check the DHCP on a router, which is on a different network. So first thing first, the basic DHCP to get the point straight. So let me go ahead and pick up a server. That's somewhere here. And we'll get a switch as well. Somewhere there. And let's get 3 laptops here. 1, 2, 3. Okay. Let me connect them quickly. From laptop to switch, laptop 2 to switch, laptop 3 to switch, and finally switch to the DHCP server, which is right here. All right. Now we are going to name this guy. Let me just quickly pull it somewhere like this so you can see it properly. And let me name this as the DHCP server. Okay. Right. So we are going to ensure that we configure this server as the DHCP, and then all the laptops which are connected with the help of the switch, they will be automatically be assigned with the IP address and the subnet mask and the default gateway. Okay. Now DHCP says that first the client will be sending the discover packet, which is called the discover, the first step. Okay, on the left hand side. And second is that the server will be then providing a offer IP address to the client. And the client will send a request back into the server saying that, yes, this is the offer which I like. I would like to keep this IP address with myself. And the server will send back the final acknowledgement back to client saying that, all right, this IP address is yours. Okay. Now in DHCP, just remember that all the 4 steps which we say the DORA process, all of them are L3 broadcast packets. Okay. Apart from the offer and the acknowledgement, which are the number 2 and the number 4 step, they are level 2 unicast. Okay. The port numbers in the DHCP, we have got 2 ports there, which works in layer 4, 67 and 68. The 67 is the server port for the DHCP and 68 is the client port for the DHCP. Okay. So let's go ahead and first of all configure the server as a DHCP server. We're going to go here and first of all I will go to config, desktop, IP configuration, and the address for DHCP I will give like 1.1.1.100. Okay. Subnet mask, let me just make it /24 255.255.0. Default gateway, I will give it 1.1.1.254, and DNS server, let's keep it blank. Once we are done with this, then we are going to come to services. In the services, I will click on DHCP here on the left hand side and I will turn it on. Okay. Now it's got a pool name. I will keep the pool name as same it is, like server pool. Default gateway, let me change that. That is 1.1.1.254. DNS server, I will give it the IP address of the DHCP 1.1.1.100. And when it comes to the starting IP address, I will say we are going to reserve the first 10 IP. And from the 11th IP address, we are going to assign to the laptops. So I will say the starting IP address is, let's say 11, and subnet mask, all is good. Maximum number of users, I will make it, let's say 200. Okay. Once all is done, then I'm going to just go ahead and click on save, and these server configurations are saved. Okay. Now in this case, if you just go to the laptop and if you just go and assign the DHCP, like change it from static to DHCP, now in this case, the IP address and the default gateway will be automatically assigned to the laptops. However, before we do that, we are going to check how the DORA works. So I will make it a simulation process here and show you how the packets are going forward. Let's make it show all none, edit filter. And in the edit filter, I will choose only the DHCP here. And if I want to make the port numbers or see what's happening in the port level, then I have to choose the UDP, right? That's what the 67 and the 68 ports are. So once all is done, I will just close this and let me go to this laptop and go to the desktop IP configuration, and I will change from static to DHCP, and let's see how the packet flow happens. The moment I change to DHCP, let's just minimize it. Okay. This is the first packet, which is called the discover packet. Okay. You can just click on this and check what's going on there. And you will see that in the discover packet, your layer 4 is of course from port number 68, which is the source. So from the laptop, the client is 68 and it's going to the server, which is 67. In the layer 3, the IP address is not assigned yet. So we are seeing the source IP as 000 and the destination IP is a broadcast, which is 255.255.255.255. In the layer 2, we are seeing that yes, this is the MAC address of the laptop and it's going to a broadcast, right? Now, let's move forward and see how the discover packets are going. Choose this, it will go to the switch and you will see that the discover packets are broadcasted to all the devices connected. I click on next, it's going to all the other laptops. Now the laptop 1 and the laptop 2 is going to discard it. Why? Because it's not matching with their port numbers. The port number is 67 for the server and the 68 for the client. So it's not matching, they will discard it. It's going straight to the server, right? So once that happens, then we are going to go for the second step, which is offer the server to the client. So let's go forward and you will see the packet is coming from server to client. Let's check this packet and see how it is, what it looks like. So in means prior to the switch and out means after the switching is done. Okay, so in means that it's coming straight from the server C087 and it's a broadcast. Out means again the layer 2, it's same coming as a broadcast. So the offer also is coming as a broadcaster, right? Now once I do that, let me just move forward and you will see that the packet is going to all the other laptops and will be discarded by the other 2 laptops, and this laptop picks it up. Okay, so this is how the offer looks like. And if I go to inbound PDU, let me see if any IP has been given there. See, source IP is coming from 11100, right, which is the server. And is there any client address which has been given? Oh yes, of course, the client still here is that 1.1.1.11. So that's kind of the client address which has been given as an offer to the laptop. Now the laptop has to accept it and say that, yes, I like this offer. And it will send the request back to the server saying that, yes, this is something which I would like to assign to myself. And the server will finally send the step number 4, which is the acknowledgement. So step 2 is done, the offer. Now step 3 is the request part. So from the laptop, it's going back to the server. Let's see how the packet looks like here. And it will be again from the laptop to a broadcast, and again from the laptop to a broadcast here. Okay, and if you go inside this, you will actually find the inbound stuff is something like this. The source IP is still 0 because source IP is not assigned yet. It's only a client IP being given, and the validation is going on. Will they like to take it or not? And this is the client address. Okay. So that's all about the request going back to the server. And again, these 2 laptops will be getting it as a broadcast. They will cancel it because the port numbers don't match. And the server final step is the step number 4, where this server will acknowledge the fact that the laptop is okay with the IP address and will say, all right, I got the point that you like the IP address and you're going to keep it. So moving forward, the server is going to send back the packet to the laptop. And this stage, let's see how the packet looks like. The acknowledgement packet will be here. And if you have a look into this, you will see, of course, it's coming as a broadcast. Inbound PDUs, source IP 100, it's coming up, right? This is prior to the switching done. And your client address is 11111. Outbound means after the switching is done, then your source IP is 100, like 111.100. And your destination, your subnet mask is 255. If I go into this, your client IP address is 1.11, and it's showing the server address as well, 1.100, right? Now this point of time, if I go to the laptop, will you be able to see the DHCP? Let's see. No, the DHCP is still not there. The DHCP will only be there when that particular offer or the acknowledgement in a packet is coming back to that particular laptop. So the moment I say forward, the packet is coming back to the laptop. The laptop 1 and 2 will be discarding it because of the port numbers, and laptop 0 will be taking it up. Now here, if I now click on this laptop and check the DHCP, the IP addresses came up. IP, subnet mask, default gateway, and the DNS server. So that's exactly how the DHCP works. The process is called DORA process. Okay, just have a check on the packet tracer, how the simulation works, and you will get a proper understanding about how the broadcasting is happening and how the unicasting is happening at the L2 layer. All right, and remember specifically the port numbers, 67 for the server and 68 for the client, and that will ensure you that yes, with the help of the port numbers, the laptops are either accepting the packet or discarding the packet. Okay, now that's about your simple DHCP. I can just stop the simulation here, and if I go to this laptop 1, maybe I can just go there and I can just configure the DHCP. It will be coming up immediately. 11112, right? And similarly for laptop 3 also, you will see the DHCP will start working, and that is 11113, right? Awesome. So that's about the basic DHCP. Now I'm going to take you through a step where DHCP I will be showing you with the help of a router. If you remember the initial VLAN labs where we have done the DHCP on the switch and on the router as well. Now here we are going to do or configure a router as a DHCP server, but on a different network. And then let's see how that works out. So first of all, let me quickly take away this topology. And let me just go ahead and pick up 2 routers. Okay. And then let's pick up 1 switch. And we will pick up 3 laptops. Okay, 1, 2, and 3. Cool. Now let's connect them. Laptop to switch, laptop 1 to switch, laptop 2 to switch, again switch to router, and router to this router. Okay, let me take this off, zoom it a bit. Okay, and I'll place it in such a way so you all can read it and it shows properly. Otherwise it's a problem if you cannot read that. Probably like that we can all read it. Let's see. Okay, this is fine. All right, now let me go ahead and assign some IP address. So in this particular laptops, I will go with, let's say 10 this time, 10.1.1.1, and this one will be, let's say 10.1.1.2. Okay, and this one is 10.1.1.3. Right. This particular is the default gateway that will be 10.1.1.254. This portion we can keep it like 1.1.1.1, and this we can keep it like 1.1.1.2. Okay, now this particular router I'm going to name it like DHCP. So DHCP underscore server, and that is the DHCP server. Okay, now let me quickly go ahead and configure the routers, and then we are going to talk about enabling the DHCP on the router, and let's see how that works out. So first thing first, I will get into this particular DHCP server, and let's start off. So enable config T DHCP server, right? So I will just change the host name, DHCP underscore server, and it's done. Gig 0 is 1112. So gig 0/0 IP address 1112. I'll make it 255.255.255.0, and say no shut. Now, since this particular network is 1 and this is like 10, I have to enable some kind of routing there, right? So I will make it OSPF. I'll give it IP OSPF, process ID 1 and area 0. Okay, turn on the OSPF in that particular configuration and we are done with this. Now, similarly come to this, and this I will be config T. This I will maintain the gig00 as 10.254. So interface gig0/0 IP address 10.1.1.254 255.255.255.0 no shut, and I will also maintain the OSPF loaded here process 1 area 0. Okay, similarly interface gig0/1 which is 111 like 4 ones, so IP address 1.1.1.1 255.255.255.0 no shut, and IP OSPF process ID 1 area 0. Okay. Okay. Also, I will change the host name here. Host name is R1. Okay. So this OSPF will take at least 40 seconds to load up because that is the loading time, the wait time, right? So let's wait for that particular time. And what we're trying to do here is that once the OSPFs are loaded, we will check the routes and find out if the routes are showing in the router right here. Because the rule is that if you want to enable the DHCP, okay, on a device, then first of all, that network must be visible on that particular device. So let's say using this particular router as a DHCP server, if I want to configure the IP address for this laptops connected in 10.1 network, then I have to ensure that the 10 network is showing up in this particular DHCP server. If it's not showing up, then there is no point in doing that because it will not happen at all. So our first point to validate is that if the 10 network is actually showing up in the DHCP server router. So let's see how the loading has happened. We will come and check. Do show IP OSPF neighbor, and it's full BDR, so it's all done. Now I'm going to check do show IP route. Okay, and cool, the 10 is showing up here as the OSPF protocol. Fantastic. That means that sitting at the DHCP server, I can actually see the 10 network, which is awesome. Now it means that I can go ahead and enable the DHCP on this router. So my first step will be IP DHCP, this command you all know, pool, and I will give a name there. For the pool, let me just create a name somewhere here. Probably this bunch of this laptops, I can give them a name, something like, let's say CCNA. Okay. Now, once I give that name, I can actually go here and I can say pool name is CCNA, enter network. Okay. 10.1.1.0 255.255.255.0 enter. Then it will say default router 10.1.1.254 and also your DNS, right? Your DNS can be configured from here. DNS server 10.1.1.254. Okay, press enter. Now these are done, right? Now we can actually come to this laptop, which means, and we can actually ensure that DHCP will be working. So I will go to this laptop, I will go to desktop, IP configuration, DHCP. And you will actually see that DHCP will not work. DHCP will fail. Okay, DHCP is failing here. And that is why I wanted to show you this topology. So the question is that why DHCP failed? We have done all the things correct, right? We have ensured that this particular DHCP server is seeing this network from here, 10.1. We have also ensured that we have given the correct commands of the DHCP in the router. So the router is now acting as a DHCP server. Then what happened that these laptops, they cannot pick up the DHCP. So the problem here is that we are sitting in different networks. And if you are sitting in different networks, so understand one thing, your packet is falling somewhere. Your discover packet. So let's go through the simulation first and find out where the packet is falling. Then we will come to the solution. So edit filters, I will just go ahead and put it DHCP miscellaneous. I will give it UDP, and let's go to this laptop IP, change it to DHCP, and let's see what's going on there. First of all, this is the discover packet, right? DORA process. So click on this and say, see what's happening. Layer 4, 68 to 67, fine. Layer 3, IP is 0 and is going to broadcast, fine. Layer 2 is going from all the A's to broadcast, right? Now, till here it's okay. Forward is going to switch, forward is going to all the devices, and you will see it is being dropped by all the devices. Not only these two laptops, but even this router has dropped this particular packet right here. Okay, now that means that that particular packet was a broadcast and that was dropped by the router R1. So let me just show you why it happened and explain to you why it happened. This is actually R1, right? Not router 0. See, the basic function of a router is that it is going to stop broadcast domains. A router is a device, okay, which is used for the purpose to stop the broadcasting. So if your discover packet is a broadcasting packet, that will definitely be stopped by the router. And your router will not allow that packet to go forward to the interface, which is gig 0/1, which is finally being connected to 1.1.1.2. Okay, so that is why you will see that in this case, the DHCP failed. Now, how to solve it? The way to solve it is very simple. We have to go to the interface of the router and we have to add in a command called IP helper address. See what happens, IP helper address is a command in a router which will help you to convert the broadcast to a unicast. So if your discover packet is going to a broadcast to say the interface gig 0/0 and drops here, right? Then you have to give the IP helper address command there to ensure that broadcast is converted to unicast and your packet is going to reach this particular destination 1112. Okay. Now, before I do that, I will also ensure one more thing. I will change the MAC address here. I will make this laptop as the MAC address A. Uh, this interface gig 0/0, I will make it the MAC address B. Gig 0/1, I will make it MAC address C. And again, to this particular router, gig 0/0, I will make it MAC address D. So when we go through the simulation, it will be easier for you to get the point, how the flipping is happening and how the MAC is being carried from A to B to C to D. Okay. So let's go to the laptop first, laptop number 1. And let me go ahead and change it. Fast Ethernet. I made it all A's. And if I go to this particular router, then my command will be do show ARP. From the ARP, I can find it out. Gig 0/0, which is connected to 254 is this one. So this is my MAC address. So I will just pick it up. Okay. Copy it. And I will go to the interface gig 0/0. And there I will say MAC address, paste, I'll make it B. Okay. B, 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 done. Similarly, I will go to interface gig 0/1, which is connected to all the ones. So basically this guy is my other MAC ID, and I will copy this and put it there, paste, and I will make it C. All done. Okay. Now let me come back to this router. Sorry, this particular, hold on. Yeah, this particular router, which is, okay. And here I will again see do show ARP. And here 1112. So this is my MAC address. I will take this guy and copy this, go for interface gig 0/0, and then go for MAC address, paste this and make it D. Okay. Now, once this all is done, let me close this. Now that I did only to make sure that once I run the simulation, you will get the points, how the packet flow is happening. But the way to solve with the help of one single command will be right here. I can just go here and I will go to interface gig 0/0. Okay, that's the one, right? Where we have got 254 and I will, and where the packet is dropping, right? Because of the broadcast. So I will add their IP helper address and I will type in the actual address through which it should go for the destination. So the destination here is that my broadcast here should be converted to the unicast and the packet should reach 1112. Okay, so I will say helper address 1112. Think of the IP helper address as a bridge kind of thing where you know just put your foot on the bridge and you reach to the destination IP which you want for. Okay, press enter and we are done. So now let's go ahead and run the simulation and let's see how things are working. So I will go to show none, edit filters, enable DHCP, and here we enable the UTP. Once that's being done, then let's go to this laptop and turn it to DHCP. I'll just push it off and turn it to DHCP now. And let's see, this is the discover packet. Okay. So it's going from A to broadcast. The IP address is not there yet. So 0 to 255 broadcast, and the port is going in the layer 4, which is 68 to 67, right? Now, let's move forward and let's see if the packet is dropping this time. So let's move forward to the switch, from the switch to all the laptops. Now these two guys will drop it. Is this guy dropping it? Let's see. Actually, no, this is not dropping it, right? If I move it, it will straight go to that particular router. So if I take it, so now what happened? So let's check it up why that drop did not happen. So if I go to this for further packets, let's say switch to R1. Okay, this one. Now you will see that in this case, the in layers, like prior to the switching, it was A2 broadcast, and the moment the switching happened, after that, due to the IP helper command, here it is coming from straight C to D. So it's not going to the B at all. Here the source IP is 10.1.1.254, which is the default gateway, and the destination IP is 1112, which is the DHCP server, and your layer 2 is happening from C. C is this guy standing right here, gig 0/1, right? So from C to D it is going. The MAC address is C and this particular MAC address is D. So that is what's showing up here from C to D, right? And that is why, so the packet is switching. It is not taking that exact format where it will take a complete broadcast and drop it. It is switching from the broadcasting to the unicasting format, right? So once that's been done, then the server is going to send the offer back, and the offer is going to come here, coming to all the devices. This two guy will drop it, and it's going to this particular laptop, right? Let's see what is the offer. So when the offer comes in your layer 2, it is coming from B to broadcast. B is again your this particular gig 0/0. So basically from B it is coming, and it's coming to all the devices. These two guys will drop it because of the port numbers, and this guy will accept it, saying that yeah, that is mine. Okay. Again, from the offer, we know the request will be going back to the server and to all the devices. They all will drop it and will straight go to the server, and the server will say, okay, fine, I think you like this IP address, you can take it. And that is the acknowledgement coming back from the server. And here you find this guy will be now having the IP address, right? So that was the demonstration of the IP helper address, how that works. And when you are in a different network, then your DHCP server should be having that IP helper address to the router to ensure that the broadcast is converted to the unicast, and then and only then your DHCP will be able to work. If I come now, you will see DHCP will work absolutely fine now. 10.1.1.2, and you will also see if I go there, that is coming to 10.1.1.3 along with the default gateway and the DNS server. Right. So that's all about the basics of the DHCP and the DHCP in a different network. I hope you liked it. Thanks for watching. Cheers. All right. Welcome to the SSH, CDP, and LLDP lab. So we are going to use the same topology which we have used for the DHCP. And now let's go and first of all configure the SSH and find out how it works. So in remote access, we normally use two ways to do it. One is the telnet and one is the SSH. Now these days we do not use telnet much. We normally use SSH because of the security reasons. The passwords are encrypted. And here what we're trying to do is that just pull up annotation here quickly. So the plan is that we will try to do SSH from, let's say, laptop number 10.3 to this particular DHCP server. So we are going to enable the SSH on the DHCP server and ensure that the laptop 3 can go to or take a remote access of the router with the help of SSH. So let's start off. Let me take this annotation off. All right. So for SSH to work, we have to ensure we follow few requirements there. Number one is that we have to ensure there is a host name for that device, like the router here. Second is that we need to have a username and a password for the device, because once you take the SSH, there should be a username and password which will prompt you and which you should be knowing. The third one is that we should also be having a key there, a cryptographic key, and we can have the key to the next level. Like by default, the key size will be 512 and we can make it 2048. And that's called the RSA key through which we can generate the cryptographic key. Okay, so once again, host name, your username and password, your domain is needed, like the company name.com or your domain name, like whatever it is, and a cryptographic key. Once these requirements are being fulfilled, then we can just get into the line mode of the particular device and we can configure the SSH. So let's start off. If I go into the router, our steps will be starting. The first thing is that I'll be getting into config T. Now, we already see that the host name is configured here, DHCP underscore server, right? So our steps will be username, password, username, I'll give it U1 and password U1 again. Done. Once I'm done with the username and password, then I will give IP domain name, basically the domain name of the company, the company.com or anything which you like, let's say ABCD. Okay. Once I've given the domain name, then my next step will be to generate the cryptographic key. So for that, I will type in crypto key generate and RSA. Press enter. The moment I do that, it will tell me that I can make it like 512, which is the default one. I can make it maximum 2048, which I'm going to do right now. Or I can decrease the key size also, which is 360. Okay. How many bits in the modulus? And I will say 2048. Press enter and the key is being generated. So these are the few steps which you have to do on the device to ensure that your SSH can be configured on the device. Once we have done this, the next steps are simple. Okay, we have to go to the line mode of the device, line and question mark. Now we will choose here VTY, which is called the virtual terminal. Okay, I will say VTY question mark again. And then we have to choose the number of the concurrent users who can use the SSH. So let's say I have got 10 users who you want to use the SSH at one shot. You can put 0 to 9. Okay. Here I will like only, let's say 2 users to use it. So I will say 0 to 1, which means 2 users can concurrently log into the device using SSH at the same time. Press enter. Okay. And your next step will be transport, okay, question mark, and you will say input or output. Now we will go for the input because the input says define which protocols to use when connecting to the terminal server. So I will say transport input, like while you connect to the terminal server or the remote access, then which protocols to use. And question mark, the protocol will be either SSH, okay, or telnet, or you want both of them, or you probably would like to remove all of them. Maybe they all are pre-configured and you would like to remove the SSH and the telnet. So here I will go for SSH only and press enter. And my last command is login local, which basically means that whatever the username and the password I'm going to log into the device using SSH, they should be locally stored on the device as well. I will say login local and press enter. Okay. Now that is the configuration of the SSH. I will exit from here. I'm done. Now let me verify it from this laptop whether SSH is working or not. So go to the laptop, go to command prompt. Now, in case you forgot how to take the SSH command, you can just type in SSH and press enter. And you will see that is the command syntax which the command prompt will show you. SSH space -L space username space target IP. So I will type in SSH space -L. Username, I know that U1, and target IP is this particular router, which is 1112, right? So I'll type in 1.1.1.2, press enter. Immediately is asking the password. I will say U1 again, press enter, and you are connected to the DHCP server. So basically you are connected to the device using SSH. That's all, okay? I will say exit and come out of this. Very simple, pretty straightforward. So that's all about the SSH. The remaining two commands which I'm going to show you is the CDP and the LLDP. Now, CDP is basically a Cisco command, okay, and that is used to find out that how many directly connected Cisco devices are there connected to the interface or the device which you are plugging in the CDP command. So by default, the CDP is enabled on all the Cisco devices. And once you type in, like, let's say show CDP neighbors or details, then immediately it will show you that what are the devices, like Cisco devices, which are directly connected to the device. Now, only one instance you have to be careful. If your device is an edge router and it is getting connected to the internet, okay, then you need to disable the CDP on that particular edge router. Why? Because somebody on the internet can, go to your router interface and they can type the CDP command and they can know that what are the devices connected and what is behind the device, right? So it's always a good protocol to follow, that on your edge routers or devices which are going beyond the firewall, from there the CDP can be disabled. All right, CDP is a very simple command. I can just go there to DHCP. Let's say here I can type in I'll just come out of this entirely and I will say show CDP neighbors, press enter, and immediately it will show the neighbor which is there, which is R1. So neighbor of this guy is R1, which is this router, right? And it is on the gig 0/0, which is this interface, and the whole time is showing. So CDP, if you remember the PowerPoint slide in the beginning, it is 60 and 180, right? So 180 is the whole time, so 174 fine. Capability is R, which is the router, and the platform is showing Cisco 2900 model and so on, port IDs. Now you can also go for this one, show CDP neighbor detail. Okay, press enter, it will show in detail stuff there, like the device ID is R1, your IP address of the device is 1111, your neighbor actually, the model name of the device Cisco 2900, capabilities router, interface 00 at your end, and at the far end the outgoing part is 0/1, which is basically 00 at this end, and the far end is 0/1. Okay, and so on. So these are the details which the CDP will give you: the host name, the device model name, the iOS version. Okay, these are the different stuff it will show you. See, the version of the iOS is showing up right here, version 15.1, right? Okay. We can go also to this particular router and check up how this CDP looks like. I can just go there and say enable show CDP neighbors, enter, and you will see both the DHCP server and the switch is showing up there. Basically, those are the two neighbors. If you want to know the details, then neighbor and details. That's about it. It will show in detail about all the stuff there, right? Very simple. With the usage of this particular command only, you can know what are the devices which are connected to this device directly. However, the catch point of the CDP is that it will only show the Cisco devices. Now, for non-Cisco devices, you have to use the command called LLDP. So let's first of all check how that looks like, LLDP. So I will go show LLDP, let's say neighbors, enter. It tells me very clearly LLDP is not enabled. Okay. Now, LLDP is the protocol which will help you to find out the devices directly connected to your device, which are or which can be Cisco or non-Cisco as well, any which one of them. Okay, so if I want to configure or make sure the LLDP is enabled, then I have to do two commands there. First of all, I will go to the config mode, and once I reach there, I will type in there LLDP run. Done. That's on the configuration mode. Okay, and then I have to go to the interfaces and type in some few more commands. So I will go to 00 interface gig 0/0, and I will type in LLDP transmit, and I will type in LLDP receive. That's all. Okay, similarly I will go for interface gig 0/1, just one more, and I will type in LLDP transmit and LLDP receive. That's it. On this end also, in this router, I will do the same thing. I will go for configuration mode. I will type in LLDP run, and I will say interface gig 0/0 LLDP transmit and LLDP receive. Similarly, I will say 0/1 LLDP transmit and LLDP receive. All done. Okay, now exit. Now let's check here how the LLDP is working. So I will go there and I will type in the same command, exit do show LLDP neighbors, and see it's coming up. Router R1 gig 0/0 on this side, the local interface, and the far end is gig 0/1, 120 is the whole time, Again, for the whole time, it is 120 versus 40. And for CDP, it is 30, for CDP, it will be 60 versus 180, right? And here it is 120 versus 40. Okay, just have a check on the first slide where I showed you the whole timers, and the capability is a router. Similarly, if I go there and type in the LLDP commands here, it will be showing do show LLDP neighbor, let's say detail, okay, and you will see it displayed, right? So that's kind of your detailed about the SSH, CDP, and the LLDP. Have a check on them. Just try it out on your packet tracer. It's very, very simple. And this was a very short lab because I just wanted to show you what the commands show and how they work and so on, especially the SSH one, right? All right, with that, we came to the end of the lab. I hope you enjoyed it. Thank you for watching. Cheers. Welcome to our last lab of the entire course of CCNA, and that is IPv6 lab. Now, before we get into the IPv6 lab, let me just share a few key points on IPv6. So from the exam standpoint, you may not be getting too much questions on IPv6, maybe a few standard ones like the syntax, is that correct or not, or few questions on does this particular prefix will make it a private or public and so on. Apart from that, you will not be getting any labs or any specific configuration on IPv6. Okay. However, if you look into the CCNA books, yes, there is a little bit of concept there on the IPv6. And here I'm going to share with you a little bit of lab to ensure that you understand the key concept of IPv6. Now, IPv6 has got few key points, which I'm going to share with you prior to we start the lab. If you just have a flashback of the subnetting lesson which I shared, all the key points of the IPv6 has already been shared with you. Number one is 128 bits. Okay, so the number of the IPs in the IPv6 is very, very huge. It's large. Like if you're looking into IPv4, then the maximum number of the IP address that we can have from IPv4 is 2 to the power 32, which is coming down to 4.3 billion IPs, right? Which is good. But again, as the IPv4 has been used, in a very, very wide fashion, there is a crunch of the IP address v4. So IPv6 is 2 to the power 128. That brings you to a trillion of IP address, and that rescues you from the ever crunching of IPv4. Okay. Now, out of the 128 bits, 64 are for network and 64 are for host part. So IPv6 is 8 hexabits. Hexabit means that it's got a mixture of alphabets and numericals, which is like A to F and 0 to 9. And that A to F is 6 and 0 to 9 is 10, which means 10 plus 6, that is 16 bits is there in each hexabit. Again, in IPv6, we do not have any classes. Like in IPv4, you have got the classes, class A, B, C, D, E. In IPv6, we do not have any such classes. Also, when you go through the labs and when you go through the book, you will find that there are a lot of ways to compress and write the IPv6 in a compressed fashion. Like if there are 4 zeros that can be represented as one single zero. Or if there is a contiguous set of zeros like 0000 followed by 0000, then a double colon or a double dot can be used to represent it. Now, IPv6 has got 5 types. First of all, number one is a private. If you have a prefix of FD in front of the IPv6, it's a private IP. If it's got a 2 or 3, it's a public. A loopback is 1/128. Okay, these all are I'm just sharing this with you in the key points. From the exam standpoint, you just have to go through a few questions in the CCNA books, and that's more than enough. But like I said, that yes, it's good to understand the few basic concepts of IPv6. Multicasting IPv6 can be used in 4 ways. So FF02 followed by 9 or A or 5 or 6. Now, unspecified. If you write the IPv6 like :/0, then that particular thing is used for the default routing, because the double colon will be used for the unknown destination and your 0 is used for any subnet mask. All right. Now, having said that, let's get into a quick lab and you will get the points very quickly about IPv6. Okay, so let me go ahead and quickly pull 2 routers here, and let me put one here, another one here, and connect them quickly. All right, we are done. Let me just increase the or zoom it basically. Yeah. Okay. Now I'm going to give some loopback address here for the first router. I will say loopback. Loopback will be, let's say, 2010, and I will write it : 1/64. Okay, so think of it that 2010 : 1 as the IP part and the 64 is the network part. Okay, so that is the loopback here. I will say loopback 1 here, and here I will add the loopback 2. So loopback 1 here again, and this one equals to 2020, and I will say like a different network, right? So 2010 is one network and 2020 is different network, and I will say 1/64. Okay. Now gig 0/0, there I will add one IP address that will be 2012 : let's say 1/64. Okay, that is one, and again here I will be adding 2012 : 2/64. Something like your 1.1.1.1 and 1.1.1.2. Okay, I'm just changing the last digit here, 2. So with that, we have finished the configurations here, and then let me quickly arrange it. Okay, and this guy comes up here, and also probably I will just keep it here. Okay, and also I will just change this. I will make it R1, and this will be R2. All right. So let's go ahead and configure the routers. Okay, then I will show you how the static routing is done for the IPv6, and then also I will configure the OSPF and show it to you on the IPv6. So very simple. I will go to router R1 first and say no here, enable config T, hostname R1, right? Now, first thing first, IPv6 by default is not enabled on the routers. So I have to enable the IPv6. How do I do that? IPv6, and I will say unicast routing. That's the command which I have to use. Press enter, and once you do that, your IPv6 is enabled on the router. The remaining part is simple. I will just go to interface loopback 1, and I will assign the IP address. Here I will just change the command to IPv6, and I will say address. And what is the address of the loopback 1? I will write it exactly as it is: 2010 : 1/64. 2010 : 1/64. That's all. You can give a no shut here, but in loopbacks we normally don't need a no shutdown. Then I will go to interface, the next one, gig 0/0, and I will type in the command again, IPv6 address. Here it is, 2012 : 1/64. Exactly right like that, : 1/64. Okay, press enter, and I will say no shutdown, enter. So that's all about my router R1. Exit from here. And now I will go to router R2 and do the same stuff on the router R2 as well. Enable config T, hostname R2. Again, here also I will type IPv6 unicast routing. Okay, once I've done that, then interface, loopback one, IPv6 address. And what is the address? 2020 164, right? 2020 1/64. Enter. Give a no shut. Again, interface gig 0/0, and that is 2012 2/64. IPv6 address 2012 2/64. And I will give a no shut here, and we are done. Okay. Now, once we have configured the routers, let's check if I can ping from R2 to R1 loopback one. So I will say do ping, and the R1 is 2010::1, right? That is the IP address. So 2010::1. Is it pinging? Let's see. It will not actually, right? Because this particular router R2 is still not knowing about the network 2010. Now, how do I find it? I will say do show IPv6 route. Enter. Do you see 2010 anywhere? It's not, right? 2012 is there, 12, 20, 20, but not 2010. So again, we'll follow the simple process of static routing. I will say IPv6 route, okay? And I will add that network here. So 2010::, and I will not add the one. If you remember the static routing on the IPv4, we were not adding the complete IP address. We were adding the network, right? So here it is /64. That's the network. And the next command will be the destination hop. So the destination network and the next hop. The next hop is 2012:1, right? So 2012::1 and press enter. Once you have done that, then try the ping. First of all, let's see the do show. And now you see the 2010 is coming up here, right? Clearly showing. Now go for the ping command, and it's working, right? Similarly, I will go to router R1 and I will check, can I ping 2020::1, right? That is the loop back of the R2, right? 2020::1, right? And it will not ping because here also we do not have the 2020 ping added. So first of all, we will check the IPv6 route and find out. So I will say do show IPv6 route, and you will see that 2020 is missing here, right? So I will do IPv6 route, and I will add that 2020:/64. Remember, only the network has to be added, and the next hop is 2010::2, right? Is that the one? Sorry, 2012::2. So 2012::2. So 2020:64 and 2012::2 is the next hop from the router R1. Press enter. And now let's see if the do show is working. See, 2010 is showing up right here. And 2020 is also showing up right here, right? So 2020 is showing up, which means now if I do a ping, will it work or not? Do ping 2020, and it's working, right? So that is the static route concept of IPv6. Very simple. Now, next one that I'm going to show you is the OSPF. So first of all, I will take off the static routes. How do I do it? I will go to the static route main command, and here I will just say no. It's done. Now can you ping? No, it will not ping, right? Similarly, I will go to R2 and take off the static route command, IPv6, just put a no there. And can you ping now? No, you cannot ping now, right? So come back to R1, and now our next step is to OSPF. Now, again, we are starting from scratch. Whenever in IPv6 you want to configure any form of routing, you have to ensure you're using the command IPv6 unicast, right? So IPv6 unicast routing is the must command, and then only your IPv6 will be enabled on the router. So on this, I will say OSPF, which is IPv6 router, okay? OSPF and the process ID, let's say 100. Press enter. It will ask you that router ID, no problem. I will just say router ID and say 1.1.1.1, enter. And now I will get into the interface. Interface loopback 1. And here I will add IPv6, OSPF, process ID 100, and area is 0. Enter. Similarly, you change this from loopback 1 to gig 0/0, and you give the same command, and we are done. Okay. Now let's come to R2. R2 also give the same command, IPv6 unicast routing. So your IPv6 is enabled. And now OSPF IPv6, you will say router OSPF process ID 100. Okay. Once you do that, again, your router ID has to be configured, which is 2.2.2.2. Enter. Now you say interface loopback 1, and you say IPv6 OSPF process ID 100 and area 0. Similarly, you say interface gig 0/0 IPv6 OSPF 100 area 0. We are done. Okay. Once we are done with this, then have a quick check if the OSPF is showing up. How do I check that? Do show IPv6 OSPF neighbor, and you will see 1.1 is showing up, full DR, right? It's absolutely fine. So here I can also check like this, do show IPv6 route, and you will see the OSPF is showing up right here. OSPF route is showing up, the 2010 from R2. Basically from R2, the 2010 is showing right up here. Similarly from R1, I can have a double check. Let's see. I will say do show IPv6 OSPF route. Do show IPv6 route, not OSPF, but route. And here you will see the OSPF 2020, which is basically right here. Okay. So that's all about the IPv6 lab. Like I said, from the exam point of view, you may not find any questions on lab, only a few questions on the syntax. Just get the concept correct. Just know the syntax. Just know that when to use the double colons. Now there is a catch with the colons or the double dots. The double dots can only be used once in a line. It cannot be used twice. So let's say you have got 0, 0, 0, 0, then 0, 0, 0, 0 again, then you have got 1, 2, 3, 4. And on the right hand side of the 1, 2, 3, 4, again, you have got 0, 0, 0, 0 and 0, 0, 0, 0. So there are two ways to write this. Either you can put a double dot on the left hand side of 1, 2, 3, 4 and then write 0, 0, 0, 0 and 0, 0, 0, 0. Or on the left hand side you keep the zeros, say 1, 2, 3, 4. On the right hand side you convert the zeros to dual dots. Okay, but you cannot put like double dot 1, 2, 3, 4 double dot. That you cannot do. You have to have the dual dots only once in a syntax. So have a check on that. The more you have the flavor of the syntax, it will be easy for the exam, because exam the questions will be quite simple and straightforward on IPv6. All right, with that, we came to the end of the IPv6 lab and our last lab on the CCNA lesson. I hope you liked it. Thank you very much for watching. Cheers. Automation. This is the last topic of the CCNA lesson and will be a brief one. So in the CCNA 200-301, we do have got a little bit of automation sprinkled, just the basics of it and a little brief of the concepts. The actual automation will be coming in the CCNP level. So automation, just want to share the basics of it and then we can stop it right here and then we can talk about it in the CCNP level. So automation, first of all, the use case. Let's say that why do we need the automation, right? So basically we need to make sure that the level of effort and the overall, the number of hours that you are putting into the particular configuration of the devices that is being reduced. So a use case can be like you have got, let's say, 100 routers, okay? And if you want to configure all the 100 routers one by one, then in the conventional fashion, it will be like going to the router one with the SSH and then configuring it, then coming to router 2, then router 3, and so on until the router 100, right? Now that's a pretty heavy kind of task and the level of effort is too high. So automation says that you really don't have to go to all the routers one by one. Rather than that, you probably can write a script in JSON language or in Python, and in the script you can mention about the IP addresses of each of the routers. The parameters can be set, and if the script is run in parallel, the execution of the script can be done with all the devices being connected to that, and all the routers will be configured at the same time without a human effort, right? So the LOE, or the level of effort, goes down, of course. And number two is that it will be more or less prone to any kind of errors, because while configuring you may be having a typo or something in the IP address, but once you write a script, a clean script of the particular commands and the particular IP address, then the chances of the errors are pretty less. Now that's where automation comes into picture. So that's a use case where instead of configuring manually the devices one by one, you can write a script and make it an automated kind of configuration for all the devices in one shot. So here, prior to we get into the concepts of the controller and automation, a little bit of the basics of the router. Okay, so let's say the router or any kind of networking device, we basically have got three planes there, three logical planes: management plane, control plane, and data plane. So in the case of a router, the management plane is the plane which will tell you how to connect the device. Let's say through SSH or through telnet or through console and so on. Okay. Control plane is the area or the plane where the actual routing magic happens, or the actual routing work happens, the intensive work. Like the packet will be coming to the interface, let's say on this side, which is, let's say, gig 0/0, and the router will be looking into the packet and then checking into its routing table and finding out the destination is matching in the routing table or not. And finally it will also find out which exit interface the packet should go, let's say this side, gig 0/1. So all that routing, the protocol level routing along with the matching of the routing table, all that magic happens in the control plane. Okay, and the data plane is the one where the switching of the packet happens from interface gig 00 to gig 01. Basically from left hand side, from the input to the output, which interface the packet should jump into, traverse to the particular destination, that magic happens in the data plane. So looking into all this, control plane is the actual plane or the actual layer in the router where all the intense calculation, traffic, all the processing, that all takes place in that particular plane, right? So here comes from Cisco says that there is a technology which says SDN, or the SDN controller. So Cisco says that if there is a SDN controller here, the controller, so all this control plane work can be transferred to the controller. Okay, all that routing magic or the processing of the router can be transferred to the controller, and the controller can sit somewhere in a centralized place from where you can control all the routers. And the way the controller will be talking with the routers, okay, with the devices here is through APIs. Okay, now the APIs which is flowing from the controller to the routers is called southbound, and the controller itself will be connected to some applications written in Java script or Python, and through that script it will flow to the controller. So the controller, when it talks with the application, that is called northbound APIs. So basically, with the help of southbound APIs and northbound APIs, your controllers will function, and they will be taking away all the control plane work of the routers into their capacity. So the routers would be free of their processing work or all the intensive routing work. Okay, so that is the basic of automation. And automation says that if you can write the proper scripts here in the applications here, using different kinds of configuration tools. So we have got certain config tools like we have got Chef, we have got Puppet, we have got Ansible. Okay, now these kind of tools, if you use and if you are writing down the configuration management with the help of these tools, which basically uses Java and Python in the backend, then you will be able to connect with the controllers and they can actually work with the devices with the help of the APIs. Okay, now the config tools, like I said, the Chef and the Puppet, they are basically built on the Ruby, and these are the tools which needs a kind of a client specific application or software to be installed on the devices. Now Ansible is one of the tools which basically is clientless. You do not need to have any client to be configured on the networking device, and Ansible works independent of that, so it do not need any kind of client to be installed on the devices. It's a clientless tool. Okay, and that's one of the main reason that Ansible is a pretty popular tool, and it is used as one of the configuration management tool. So that is the basic of automation. Okay, the CCNA, the scope will not take you through a JSON script or a Java code or a Python code or something like that. It's just the basics. What is automation? What are the different layers? What is the management plane? What is control plane? What is data plane? How a controller works? What is a northbound API? What is a southbound API? And little bit of logical stuff is there. Okay, the actual automation piece will be starting off in the CCNP level, which we will cover, and we will actually do some automation stuff there. Okay, so I recommend strongly that go through your CCNA Cisco Press books, and there you will find the entire concept about the automation, which is sprinkled on the CCNA syllabus. All right, so we have came through a long journey of all the lesson 1, 2, 3, 4, and 5, and thank you for watching with your intensity and enthusiasm for all the lessons. Thanks a lot for that. Now, coming to the next steps, what you need to do once you finish this course. Number one is that practice, practice, and practice. Okay, your conceptual things must be clear by now because I have covered all the CCNA concepts in this particular course of 5 modules. Uh, Again, go back to the book and read through them, especially go through the physical layer, the cables part, which I have not shared much in this particular course, and then go through the concepts in a very theoretical fashion, make notes, practice the commands on the simulator. Very, very important stuff, because if you do not practice, if you don't install a simulator like a packet tracer or GNS3 and really get your hands dirty on uh, a router or a switch or any of the protocols, then you will not learn uh, the fun of the commands. Okay, so ensure that you are not only learning on a piece of paper or notepad, but you're learning on the devices, you're configuring them, and so on. Now, when you practice on the simulators, I will always say that do not try with a very huge number of the devices. Don't concentrate on the numbers, which means that you don't have to configure 20 routers and 20 switches. Always pick 2 or 3 routers, 2 or 3 switches, and that's more than enough to have a concept solidly built. CCNA, the course demands that your concepts are crystal clear, because in CCNP level you will be again going through a similar kind of course content. You will be again going through VLAN, where you will learning a little bit more in VLAN, which we have not covered in CCNA. OSPF, we have covered only 40% of the stuff in OSPF here. Again, a lot of the stuff is pending, right? Which you will see in the CCNP level. So if your basics are clear here, the fundamental CCNA is clear with your concepts of VLAN and switching and spanning tree protocols and your routing, your OSPF and everything. Trust me, your CCNP journey will be a lot of fun. Now, CCNA, the old syllabus, they have changed a lot. They have removed at least 40% of the syllabus. And what they have done, they have actually, Cisco guys have actually dumped that 40% of the CCNA syllabus to CCNP syllabus. So CCNP syllabus is now much wider and much deeper. So you need to have a good foundational stuff on the CCNA, and then you can proceed on the CCNP. Recommended books, there are many actually. I will just say that yes, for reference, for deep dive, you can always keep these two books handy with you, which are extremely nice books, very well written books. TCP/IP routing, that is volume 1 and 2. People say that they are for the CCI level, but personally I feel that not only for the CCI, right from your networking journey, you can have a tab on these books and you can learn a lot from these books. Again, like I said, these are not mandatory to pass your CCNA exam, but these are something like where you can just have them handy to go through them, to dive deep, and will be really a good reference point in your entire journey from CCNA NP to IE. Okay. Finally, very important, keep a gap of 1 month before you start your CCNP journey. That 1 month is to refresh your content, to get your hands dirty and your hands smoothened out into the commands in the simulator, and then and only then you go for the NP. Don't think like CCNA and tomorrow CCNP, day after tomorrow CCI. No, you cannot do that. Don't try in a fast track way. Go slow, because this knowledge is incremental in nature. It will slowly increase and you will come to a point where you will realize that, yes, now I know this level very well. Now my next aim should be to conquer the next level. All right, happy journey.